Good morning, and thank you for joining us for part one of our five-part webinar series on Toyota's TIPROS FMS software. This webinar series will not only be a nice refresher course on Toyota's automation software, but it will give you the necessary tools you need to maximize your system's production. So over the course of the next few weeks, we'll release 5 webinars that cover a variety of topics. Today's session will serve as a basic introduction to FMS and discusses the different software options that are available. Episode 2, Core Concepts, introduces the correct setup conventions for optimized automated production. This episode will also be useful for those who are new to setting up the cell controller. Episode 3 actually goes into further detail with the cell controller, which serves as the brain of the cell. We'll be working with our in-house FMS Live, and we'll be taking you through various functions. Episode 4 talks about the heart of the cell, the RGV. Without this essential piece, lights out operation would not be possible. If you attend the 4th session, we'll show you how to keep the cell running. And then on our 5th and final entry, we'll use that to answer any questions that you may still have. We'll connect to the FMS and run through a few demos. So today we'll begin by outlining Toyota's FMS options, and then we'll dive into the basic capabilities at each of our software levels. For a quick introduction, my name is Tim Campbell, and I'm part of the marketing team here at Toyota. I've been with the company since May, and will be presenting and administering the webinar series. Joining me today is Keith Jackson, and I'll let him introduce himself.
My name is Keith Jackson. I've been with Toyota for 14 years. My main function here is FMS and just an application engineer.
Okay, so who is this webinar series for? We've designed the series for Toyota automation customers who have our rail-guided vehicle or RGV systems, as well as those with vertical pallet pools. We're hoping to inform those who may be automating in the future. Throughout the course of the series, we'll be covering everything ranging from the basics to more complex topics. So anyone that has a stake in the cell's production, including manufacturing engineers, you'll understand how to process new or existing parts through a cell, to programmers, learning our program format and tool management system, for setup personnel, understanding work offset and pallet types, shop managers, utilizing reports to improve cycle times and optimize scheduling parts through the cell, and then finally operators, knowing the alarms and working through part changeover. All of you will find this series useful. Okay, so in today's session we'll review the basic components of an FMS cell, identify the capabilities of each software level, and show you the basics of the cell controller's interface. Since we do have a lot of information to get through, we'll ask that you hold your questions until the very end. Just go ahead and reference the slide number at the bottom left-hand corner of the screen, and we'll spend some time to answer any questions you have. So let's go ahead and get started. For those of you who don't know, FMS is not a new concept to Toyota. The very first TIPROS system was installed in 1972 at Toyota's Okazaki, Japan factory. The success of this system laid the groundwork for future pallet systems and centralized computers from Toyota. Moving to 1990, FMS stacker cranes became widely used throughout the world, and this advance allowed for 24-hour production and a higher degree of workpiece flexibility. In 1995, we improved on this technology to allow for multi-machine, multi-pallet systems with rail-guided vehicle automation on our own Toyota cell controller. Since 1995, we've constantly improved on our systems and software to allow our customers to keep up with demand. Over the course of this series, we'll show you what sets Toyota apart from the rest. So today, Toyota offers robust solutions for those looking to increase production. A question that we often hear is, why automate? And put very simply, increase profit through increased productivity. Automation allows for increased spindle utilization, decreased work in progress, reduced manpower required per spindle, and less dependence on highly skilled labor. All of this then translates into a better bottom line, which can be realized in a short period of time. Typically, a standalone 2-pallet horizontal machining center will yield about 55% spindle utilization, while a single or multi-machine RGV system yields over 95% true spindle utilization. This is due to the fact that once a new job has been proven in the cell, no additional time is needed for repeated setup, first article inspection, or additional handling of tooling. So as a result, your throughput will increase while decreasing your work in process. Work is then able to be scheduled in the quantity needed, minimizing overruns and inventory, allowing for a true just-in-time system. So over the course of the series, we'll show you how this is done using TIPROS FMS. And our goal for the series is that new and current users are able to attain these results consistently using the information we provide. And now we'll have Keith introduce our options.
What do we have available at Toyota? We offer a rail-guided vehicle system, which we abbreviate RGV. RGV is a 1, 2, or 3-level pallet management system that uses a rail-guided vehicle to transfer work about the cell. The cell is multi-generational, meaning that machines that have the same pallet size but different production unit can be integrated into a system. This system is capable of increasing spindle utilization to 95%, which gives shops the ability to run lights out production, which is a huge advantage. The heart of the RGV is a single rail-guided vehicle, which is used to move pallets around in the cell. Each FMS cell is also equipped with a single cell controller, which runs TIPROS, a PC-based software. TIPROS stands for Toyota's Integrated Production Software. This unit controls all aspects of the cell, and using the cell controller is what the bulk of our webinar series will cover. A RGV cell can handle from 1 to 20 horizontal machining centers of the same pallet size. As your production need grows, you can add more machines to your system. Toyota engineering department can work out a layout that will fit your needs. Each cell has at least one station for loading and unloading parts. Larger cells with multiple machines can have up to 10 of these stations. Each loading station has its own control. If you look at the far left photo on the screen, you see two displays. The bottom display is a standard and controls the loading station. The upper screen is an option and is used for loading instructions. The instructions here can also be seen on the cell controller's computer. As you add more machines and loading stations to the cell, you will need more buffer stations to store your pallets. A cell can hold from 8 to 180 buffer stations. An option is an auxiliary station. These stations can be a wash booth, a deburring station, or an inspection machine. The system allows up to 3 auxiliary stations to be integrated into a cell. The photo on the far right shows a wash booth that one of our customers put on their system. As all machines come standard with a tool magazine, but some customers will include an option called a matrix magazine to the cell. When customers decide to automate production, it's typically because they have many part numbers they want to run in their cell. For lights out operation, you would need backup tooling for this type of production. A matrix magazine will give you that capacity. You may want to consider a matrix tool magazine. A compact matrix magazine is a smaller option. It holds up to 304 40 taper tools. The larger matrix magazine can hold up to 504 50 taper tools. In review, let's look. What we have covered is one rail guided vehicle, cell controller that runs temporal software, machines up to 20, loading stations up to 10, buffer 8 to 180. We can have 3 auxiliary stations, and quite naturally, the tool matrix magazine. As you can see, this is a completely modular system. You can add machines, buffers, and loading stations as your production need grows, which will give you the ability to run true lights out production. Now we're going to take a look at the main screen on our cell controller. So at the very top are the main function keys we use in every day, especially for setting jobs up. Down below here, we have our buffer station. This system happens to have 2 levels. All our buffer stations for the lower level is always 100. Second level would be 200. And if we had a third level, it would be a 300. So here we have pallet numbers. The pallet numbers will correct itself every time the RGB moves a pallet. This is RGB. This moves pallets from the buffer stations to the loading stations or to the machine. Down here, buffer stations, as I mentioned earlier, each buffer station has its own control. Machines, represented here, we in level 2 can get to our CNC control or our tool magazine through the cell controller. And these light gray areas here are future machines. This customer opted, when his production gets busier, he will put additional 2 machines in here. This function here, you see here, is when a pallet comes in the machine under the spindle, it starts a timer. It tells you what time it started and what time that pallet will be completed and back into our loading station. Here is an icon where we can look at if the system is in manned or unmanned mode. Over here we have our status bar. We have the status of all the pallets, which you can view from this computer or anywhere in the shop if you have the software to link this to it. And then you have our unit status. So now I'm going to take you over to Tim to let him explain the colors of our pallets.
All right, so as Keith was saying, on the Tipros display, each pallet is color-coded to show the user the status of that pallet. So yellow would mean that the workpiece is loaded and it's ready to be machined. That lighter green shows that the process on the pallet is complete and it's ready to be taken out of the cell, while a darker green shows that the pallet is done and it's waiting to be taken from the buffer station. Dark purple would indicate that the pallet is not mounted, and this will not be sent to the machine until mounting has been corrected. A light blue and light purple are displayed when you're running FMS in unmanned mode. So a light blue is unmanned 1 and would be sent to the machine before any of the light purple, which are unmanned 2. If the pallet is pink, the machine is not capable of processing the workpiece. An example of that would be if the proper tools are not in the machine's magazine. If the pallet's red, then it has alarmed out. It will not be machined until the issue has been addressed. And then lastly, if we're gray, that means that there's no setting because there's no part on the pallet. All right. And very similar to the pallets, the machines, load stations, RGVs, they also have their own color-coded statuses as well. So if it's gray, it's not powered on. Light blue means that the unit does have power. If it's a light blue, then it's ready to accept or receive the pallet, and a teal green means that it is running in auto cycle. We've got 2 different shades of purple to denote when the machine is warming up. The lighter shade shows that it is in that process, and then the dark purple shows that it has finished. All right, if the machine is yellow, then we've got a part in the machine being cut, and a purple-pink type of color means that operator assistance is required. And again, anything red would be bad as it has an alarm. RGV blue color shows that it has returned to its home position, and when machining has turned green, then that means that the machine has done cutting the workpiece. This would be request statuses that you would see. Yellow means that it's ready for loading, and if we have green, then that means that the pallet's ready to be unloaded. So again, very simple. So that's what each color-coded status in the cell controller means. And we'll move on to the load and unloading at the load station. So this is the panel where the operator controls all inbound and outbound pallets that go into the cell. A lot of these are fairly self-explanatory, so we're going to go through them fairly quick. RGV auto mode will light up when the system is in auto mode. RGV start position will indicate when the RGV is in its start position. System running will be green when the cell is in run mode. Our ready light will turn green when the cell is on and ready to begin production. There's a man auto switch which toggles between running the system in manual mode versus auto. Also, we have central control, which allows you to decide if you're running the system as a cell or if you're going to run each machine in your system separately. We've also got reset button, as well as door lock and unlock, and then also cancel, which will cancel any command at the load station. Finally, we have mounting complete, and that's when we have the part mounted to the pallet. That completes our load station controls here, and we're going to bring it back to Keith, who will take us through our software levels.
With temporals, each level builds on the next. Every function you have in level 1 is a function you have in level 2. Every function you have in level 2 is a function you have in level 3. The software is PC-based and offers 3 capabilities: transfer control, DNC, and reporting functions, and tool management. We'll dig deeper into these topics in the next few slides. All right, level 1, what we have is transfer control. The system is managed through the cell controller. All programs and work offsets are held in the machine's memory. It also includes a basic scheduling function and full routing capability, meaning that we can call all our pallets to the load station or through the machine through the cell controller. Also, we have minimum reporting capability. So it's really a, based out thing. Okay, let's talk about some of the keys we have on level 1. First thing, we have loading quantity data. This is where we can put a part in and request it to be loaded to the loading station. Next, we have work data. This is where we tell where the work is to be machined. 3, we have fixture data. In level 1, it's just a name of a fixture that we want to mount a part to. Same as base data. We can give a tombstone a name that we want to mount the fixture and the work to. Pallet data, quick reference of what is mounted on that particular pallet. Estimated machine completion gives us an estimated time when our schedule is going to be completed. New work wizard is a way to try to step you through setting up a new job. Mode settings, this is how we switch from man to unmanned mode. And regular check instruction, screen preventive maintenance. And quite naturally, we got the FMS maintenance info, Toyoda support, alarm details, some troubleshooting guide is in this icon. And we have dynamic scheduling, which is an option. So let's talk about level 2. Level 2 gives us everything that's in level 1, but it includes machine CNC screen display. That means I could double click on my machine and see the machine's control. So I can look at what part is running, what program is running, and all this. One thing about this, all our programs reside in our cell controller. So DNC will transfer all programs from the cell controller into the CNC machine. Also, we have what we call alarm replenishing. We can recover alarms from the screen. And we have full report checking here. So let's talk about some of the buttons we have here. Number 1, like I said, all our programs go in this folder in the CNC control. 2, tool on data. If I click this, if I have 2 machines, all the information on both machines will come into I can display all the information. Machining reports display all the machining status, part numbers, and what machine it came out of. Operation reports tracks machine utilization, spindle utilizations, load station utilizations. And production reports look at the overall production of the cell. And system alarm reports. This keep history of all the alarms that went on in the cell. And quite naturally, it covers the preventive maintenance too. So all this thing is logged in that. So let's move on to level 3. Now you have transfer control, reporting function, and tool management. From here, you can look at all your tool information, such as when is a tool is going to be expired. We can look at what tools are in both machines, or do we have enough runtime on each tool. So we can load our pictures here of our tooling. So this just gives you a total overlook of all the tools that's in the system, or even outside the system if we do this tool management. So we got 3 main function keys here. Tool change instructions, which we can query the machine or how long the tool is going to last if we're going to run it for 10 hours. We got individual tool presetting. This is where we could view the pictures. And we got tool database, which give you all the information about that tool, such as adaptive control, weight of the tool, how long the tool is. So all this is kept in the cell controller and can be viewed. So the overall look at all three levels are, number one is where we only get transfer control, meaning that I could bring a pallet through the whole system. Level two is I get DNC reporting. That means I could look at programs, look at each machine from the cell controller. And level three is tool management.
All right, so that does actually conclude our first FMS webinar. I know that was a lot of information to get through in a short period of time, so I do thank you for taking the time out of your schedule to join us. If you do have questions on anything we have covered today, please use the chat function or send us a question. Or you can always contact us at the number listed, which is 800-257-2985. Or send us an email at service@toyoda.com. We'll get those questions answered for you so we're all on the same page for our next webinar, which was called Core Concepts. To give you an idea of what that entails, oftentimes customers will lose operators for various reasons, and the new operator isn't able to repeat the same results. If they attend our upcoming session, we'll ensure that your throughput and spindle utilization rates are optimized. Core Concepts will premiere on October 13th at noon Central Standard Time, which is actually in just 3 weeks, exactly 3 weeks' time. So again, thank you all for joining us here today. We'll stick around for a little while to answer any questions you may have. But other than that, again, thank you for your time. All right, so that does take up our time for today. Again, thank you all for joining us. If you do have any further questions that aren't answered, please reach out to us and we'd be more than happy to help. We look forward to seeing you at our second episode, Core Concepts, which will premiere October